Let me do this. Freeze that for you. And do you have your tests that you can look at? All right, so take a look at that. If you are looking to get points back, here's what you need to know. Oh, I didn't do this the right way. Hold on. Let me go back. Let me pause this. And there, you can see that. From the no calculator, so I am going to probably do like 1 page no calculator, 1 page calculator. But for the no calculator part, you only need to know 6, 7, and 8. Now 8 are all those ones on the very back where you like log base 3 of 27, where you had to do those. You look at me.
Yeah.
Okay. Are you trying to get points back?
No.
I don't need to worry about this.
Okay.
What I'm talking about.
Okay.
Okay, so the no calculator part, 6, 7, and 8, and then on the calculator part, you just need to worry about 5 through 8, 5, 6, 7, and 8. 5, 6, 7, and 8. And those are just like the solving ones with the equations. So if you're looking at that, that's it. Those are the only ones you get problems similar to those. Hopefully it'll take, I don't know, 20 or so minutes. And then, like I said, I think I'm gonna have to divvy it up into a no calculator and a calculator. That's what I was done with it.
Oh, yeah.
Okay, for that. So no calculator part, 6, 7, and 8. And that's all you really need to know. And then the calculator part, 5, 6, 7, and 8. Okay. Am I clear? Okay. Sometimes I'm not clear, I've been told. All right, so do we just want to go through this, or you want time to do it? Time, Eddie said, I want time to do it. I got this. Gabby's like, I don't know where
Yeah.
to go. All right, so you can figure it out. And then, so you got the focus, you got the directrix, you got the endpoints. So I'm telling you, it's a parabola, so I'm no hiding anything there. Whoops. Oh, there we go. Mrs. Miller, how you doing?
Good. How are you?
Doing all right. Wendy, my voice is a little scratchy. That's usually an indication of how practice went the night before. Yeah, I don't know what it means. What do you think that means?
Oh, I thought we did that right.
We did a 2 experiments and a 3 experiments.
It's a little rusty.
All right, a little rusty.
Yeah.
You gotta take that into account.
Yeah.
You gotta take that into account. You're right.
So you divide the number.
Kind of.
Now, wait, you first of all, let's see.
Or the X of 20
It's
on one
just
side.
X.
Oh.
So it was.
That will make life a little difficult.
It's a good thing we have a short practice today.
Oh, yeah. Oh, she's shuffling through. Everybody shuffling.
No.
Get on your own with that.
Not art teachers.
Our teachers only got a word.
Don't you know? Okay. Okay.
This is tomorrow.
Feeling Eddie's eyes on. Okay, can you graph it? Can you give me all the good stuff? All right, so you're probably either to the equation or you're stuck. So let me at least get you to the equation at this point, or you're rooting through your papers trying to find something. All right, find the vertex, focus, directrix, endpoints of the latus rectum, and then you're going to graph the parabola for here. So we're able to survive on Alex on this whole stuff. Think you're okay? Maybe? All right, well, good thing we got a good review today. Okay, I'll give you that with the answers. So, y squared, you want to get, the one that is squared, okay, by itself, or all those variables, and then get everything else to the other side. So that's gonna equal negative 8x plus 28. And I said this, in another class, this is a lot of times, the biggest mistake I see is when you move something over, you don't negate it. You just kind of put either a positive 8, it's just a careless mistake. It happens, but you really just got to be conscious when you're doing that. Make sure you get that right sign, because that's going to change a lot if you don't. No coefficient in front of the x squared, so I don't need to factor anything out. And so half of 4 is 2. Square that, you get 4, and that means I'm also going to have a 4 over here. And that's going to give me y plus 2 quantity squared equals negative 8x plus 32. And so I get y plus 2 quantity squared equals negative 8. And then x minus 4 will go here. So now that's the form. That's what we call the standard form. Quantity squared equals that. You got it. You're going to have to know these forms for tomorrow. Okay, you got to know what you're looking for. Okay, for ellipses and then for hyperbolas as well. Now, what does this tell us? 4a, which way does it open? Okay, first of all, since it's y squared, it opens left and right. Or excuse me, left or right. And now you got to determine, since 4a equals negative 8, a equals negative 2. Since a is negative, that should pin down which way it opens. Which way should it open? It's going to open to the left. Okay, so this is going to open up to the left. My vertex. Now, the parabola is the only one that has a vertex. The other two have centers. Okay, the vertex is going to be 4, negative 2. And it's going to open up to the left. So I'm going to go ahead and graph it, or at least start it. 1, 2, 3. And 4, negative 2. Vertex opens to the left for that one. Now, since A is negative 2, how do I determine where the focus is? How do I determine where the directrix is? Eddie, you remember?
Y equals 4a.
Say that again.
Y equals 4a. I mean, 4ax.
Well, we got that. Is this what you're talking about?
Yeah, and then
So-
we plug it in.
So, well, all right, we know A is negative 2. How do I use that to find the focus of the directrix?
Put in the vertex with the negative 2. No.
So do you know, how about this? Can you give me the coordinates of the focus?
Yeah,
There we go. I asked the wrong question.
I got 2, negative 2.
All right, so right there, yes, that's what I'm looking
Sorry.
for. And what would be the directrix?
Directrix would be, it would be 5, no, 6, then negative 2. Or just x equals 6.
There we go, x equals 6. All right, so now the directrix, vertical line. In this case, directrix, x equals 6. And then, so our focus is going to be 2, negative 2 for that. And now the endpoints of the last rectangle, they go through the focus. They kind of give us the width. We've talked about this before. To get the endpoints, you go 2a from the focus. Okay, 2a. A is negative 2. I'll drop the negative at this point. A is 2. 2 times 2 is 4. So go 4 units up. 1, 2, 3, 4. Go 4 units down. Okay, so my endpoints are 2, 2, looks like, and 2, negative 6. And so that kind of gives me all my values there. Got it? Did we hit everything? Focus, vertex, directrix, endpoints, graphed it. All right, I think we got everything there. That's for that one. So yeah, you need to remind it a little bit. I know it's been a while since we've done parabola. All right, any questions on anything we did here? how to organize, how to set it up. All right, now 57 on that second page was, I know, a little rough. It's a good problem. Okay, it's a good problem. Let's take a look at it. And then, because if you're like trying to match up your answer with what the back of the book got, I think you probably might have, it was probably difficult. If you got it, that's awesome. All right, what's the equation? Gabby, you got the equation from 57 or the original problem?
I have it just like whenever we rewrite it, but I don't have the original.
Well, tell me what you got.
2x squared plus 12x minus y squared minus 8y equals -3.
Okay, I think it was just +3. And so you moved it over. Are we good there? Is that correct? All right, so we go through our procedure. All right, so what's your standard form for a hyperbola? Now, how do you know, all right, first of all, how do you know this is a hyperbola? Because like on the test, it's not gonna tell you. You gotta tell me. But you should be able to look at this and tell me it's hyperbola, right?
Got a -1, that goes square.
Okay, yeah, you're just looking at the x squared and the y squared. It does not matter what the x is in this y, those sign, the sign, if both of these are positive, then it's an ellipse. If one is positive and one is negative, then it is a hyperbola, okay? So that's the key. Now, if you only have one x squared, like this last problem, like you only have one of them is squared, then it's a parabola. Okay, so that's the difference. That's how you just tell by looking at it. All right, so I got an x squared positive. I got one is negative, then it is a hyperbola. If they're both positive, it's an ellipse. Well, what if they're both negative? I'm not going to throw that at you, but it's an ellipse, okay, because you can make them both positive. All right, now let's go through here. So I'm going to take out a 2, x squared plus 6x, and I'm going to fill that spot. I'm going to take out a -1. Y squared, that becomes plus 8y. That becomes plus, we're going to add something there, and so I need to counter it on the other side. All right, half of 6 is 3. 3 squared is 9. So what do I add on the other side, though? 18. 2 times 9 is 18. Okay, half of 8 is 4. Square that, that's 16. But what do I counter that on the other side? -16. -1 times 16, -16. All right, so now I got 2 times x plus 3 squared equals negative, oops, not equals, sorry, minus, I don't even need the 1 really, y plus 4 quantity squared equal, what's it equal? -1, right? Equals -1. All right, to be in the proper form, it has to equal what? That's equal 1. So it's going to change this. So I'm going to divide by -1. Okay, I'm going to divide by -1. What that does, okay, at this point, is you can treat that as a negative divided by negative. So that's actually going to make this piece what? Positive. And it's going to make this piece negative. So I'm going to rewrite my order. I'm going to make it y plus 4 squared minus 2 times x plus 3 squared equals 1. Well, it's always over a number. It's always over a squared or b squared, right? But there's one still little problem here. What's our little problem? This 2 is a problem. You cannot have it because everything we've always had, because this is kind of what we've had. All right, so if I had a number out in front, I'm just making this up. We always ended up like dividing by like a 12 or something. Or that was 12 divided by 12. And then it would work out really perfect, right? So everything worked out perfect. So that would be a 6. And then that would be x plus 3 squared. And that would be a 2. And that would be, all right, that doesn't work out nice. I got to get rid of that. And I got to make this, because right now a squared equals 1. We're good with that. But b squared does not equal 1 because of this. All right, how do I get rid of that 2? Okay. All right, here's what you can do is, well, what times 2 gives you 1? 1/2. So I can multiply, and just think about this. I can multiply that by 1/2, and if I multiply that by 1/2, I got to multiply the bottom by 1/2. So this is going to be the equivalent. It's going to be y plus 4 quantity squared over 1 minus x plus 3 squared over 1/2 equals 1. That's how we kind of make it go into the right order. This is really a 1 out in front. 1 divided by a half is 1 times 2, which equals 2. So really that's equivalent. That would give me a 2 up top. So basically whatever that constant is, I can multiply by 1 over on top and bottom to kind of get rid of it. So now a squared equals 1. B squared equals 1/2. A equals 1. B equals the square root of a half, which is going to be, now, you can, depends on how you leave it. That's either going to be 1 over the square root of 2, because the square root of 1 is 1. If you rationalize the denominator, you get square root of 2 over 2. What's your slope? What's our slope? I mean, just do like we normally do, at least like Kylie. So what would I put down for my slope?
1 over square root of 2 over 2.
Yep, 1 over square root of 2 over 2. At least that's, that's not incorrect. Now I would want you to simplify that. That becomes 1 times, you flip that, 2 over radical 2, which is 2 over radical 2. And what do I get when I rationalize that denominator? I get 2 square root of 2 over 2, which just becomes square root of 2. So if you looked, I think in the book, for the equation of the asymptotes, I think it was y plus 4 equals plus or minus square root of 2, and then x plus 3. And then what's my center? My center is going to be -3, -4. Okay. And then, no, we don't have great numbers. Like here, all right, I'm going to make my box. I got to go up 1. I got to go over square root of 2 over 2. Okay. But that's how it would work. Okay. Not everything works out perfect. But that kind of should give you enough to kind of do that. No, you're not going to see anything quite this complicated. You do need to know, like if you do get a constant up there, like you should be able to handle that. Should be able to handle that. Okay, and so for instance, what I'm saying, if you have, let's say it works out this way, like you get 2x plus 3 squared minus 4y plus 1 squared equals, let's just make up a number, 21. Right? You're like, oh, this is awful. All right, well, you still got to divide by 21. You still got to divide by 21. And so that would give you 2 times x plus 3 squared over 21 minus 4 times y plus 1 squared over 21 equals 1. You can't leave it, though. You can't leave that 2. You can't leave that 4. What would we have to do? What would that final answer look like? Okay, you're probably not going to see anything that's nasty, but it just, you need to be able to understand the procedure. Multiply top and bottom by a half. What do we multiply this one by? A 4th. Okay, and so you're going to get x plus 3 squared over 21 halves, okay, minus y plus 1 squared over 21 fourths equals 1. Okay, so that's how you would handle that. All right, now that your head's swimming, okay. All right, to review, it's probably as close to a practice test as you'll get. Okay, so it's pretty simple. I'm going to hand this out for you to do. The answer key is on here, which means I'll publish it to Canvas, so it'll have all the work, okay, and it'll go through everything. So if you get stuck, it'll all be there. Okay, so let me hand that out. You can work with somebody if you want.